when you have people that join your group that come from more traditional synthetic biology backgrounds and they're interested in learning more about machine learning, where do you direct them? Like, what kinds of things would you recommend that they do?
Yeah, it's a great question. I mean, I basically make them work through the GitHub for this particular paper. And I actually even had a couple students of mine who kind of turned this into kind of a class project. So we have this Python notebook that allows you to kind of work through at least the linear regression type of models. So yeah, it's a lot of kind of learning by doing.
Yeah.
I actually think, I think being a little bit familiar with like Python programming is super helpful for this, or maybe R, but in my lab, it's always Python.
Yeah.
I also think that kind of implementing these basic models is actually not that hard. I mean, it's so automated. There's like these linear regression and deep learning modules, and you can just kind of call them and use them. I think
it's actually a really interesting example because you have all this data available online, and that's also true of a handful of other synthetic data sets that are out there nowadays. And so it's interesting, like one of the things that people could do is pull down those data sets and try to reproduce figures from papers, but rather than working through like handwriting recognition or some of the other classical machine learning processes, you could actually do it on synthetic biology data.
Yeah.
What about for PIs who want to get involved in this and maybe are a little more like time limited? Like, do you have recommendations for them?
It's a good question. I mean, I can't, the way I got into it myself is really because I had a very good grad student like Alex Rosenberg who kind of started using it, right? I mean, it's a bit not quite answer to your question, but basically when Alex initially joined the lab, I mean, we were working on splicing, and I kind of, had a much more traditional synbio approach to that. Like we basically were trying to engineer these conditional splice constructs, build some input sensor and then have splicing control something. And it just never quite worked. And so at some point, Alex kind of decided that instead of trying to build, one thing at the time, why not make a library of some sorts and just see, kind of how the sequence in an alternative exon actually influences splicing, right? Because we had tried to engineer these synthetic exons and put particular things in there, like secondary structure with the splice sites, and it never quite did what we wanted. So his thing was like, okay, let's just make 1,000, which at the time we thought was amazing, and see what happens, right? And so we did that, and with the help of another lab like Jay Shindura's lab on campus, we were able to sequence, these results. And kind of in that process, Alex, initially he did, more basic analyses, just kind of counting how often you see certain features in a certain motif. But over time, kind of, he realized that basically using some linear regression models or something would be quite powerful. And that's kind of how I actually got into this. And so I guess in some ways, I feel like the way to get into it is just to generate some interesting data.
Yeah.
And find somebody to help with it. Like either, it could be a student or a postdoc who just is excited about computational methods and wants to pick that up, or through a collaborator. I think if you're coming from the data side, I think that's really a good way to get started.